Thanks for being here. There's been a number of presentations around the digitalization of grid, so we hope this complements the earlier discussions that happened in this room today. With a growing presence of renewable energy, storage devices, and electric vehicles, managing distribution and transmission grids using digitalized solutions has become more critical than ever. This panel will examine the progress made in managing complex grids, leading the world in integrating renewables and EVs. We'll also discuss the opportunities presented by an energy grid that must be resilient to the changing conditions in electricity supply and consumption. The panel will explore the latest grid innovations, security, and software solutions that will enable a truly resilient grid. And of course, it's important to all of us, this ongoing transformation of the grid, given it is the backbone of our modern economy. So with that, let's get started with introductions. Our panelists represent the largest distribution company and leader in renewable energy in Europe, E.ON, a leader in renewable energy investment in Emerald Ventures, and the world leader in broadband over power line solutions, Corinex. So why don't we kick off? We'll have Markus kick off the session. If you could give your background and E.ON, as well as your views of the current grid status here in Europe, that would be fantastic. Thank you.
Okay, thank you, Kathy. Thank you very much for this nice introduction. My name is Markus Hofsäß. I'm working for Bayernwerk, that is E.ON's second largest DSO in Germany. And inside this position, I'm taking two roles. On the one side, E.ON has decided to to produce its communication in a consolidated way, where Bayernwerk takes over responsibility for communication all over E.ON. And in this role, I'm taking responsibility to coordinate all the different DSOs and also to have the product management there. Inside Bayernwerk, I'm also taking the role of being head of or controlling the deployment of all our communication technologies all over Bayernwerk down to the technicians. Let me give an outside or a drawback. 30 years ago, let's say, or 25 years ago, our grids had been resilient. It was pretty easy. Power was produced in big plants. It dropped down. The plants had been rather close to where the demand was, and power dropped down from very high voltage to medium voltage until up to the end customer. The demand was predictable. We had standard load profiles. Everything was pretty easy. If there was a higher demand, okay, it was clear we need some asset. We have to enlarge or expand our grids. This has changed. Now we have production everywhere. We have it down in low voltage, in medium voltage. Power is sometimes, some days when sun is shining, pouring up to higher voltages, transported to other areas, pouring down, and all this has to be coordinated. Production is very decentralized. All these challenges have to be kept and controlled, and this is what E.ON currently is driving, and not only E.ON, for sure, all our DSOs or other power companies do have the same problems and the same challenges.
That's excellent background, thank you. And Christoph, I'll hand it over to you if you could provide your background, very interesting, varied background, as well as touch upon Emerald Ventures. I'm sure folks know Emerald Ventures, but good to highlight that as well.
Thanks a lot, Kathy, and thanks for having me. I will follow Markus. Excellent example, something about me, something about Emerald, and then my initial take on the topic. So myself, I've been with Emerald for 3.5 years, but before that was the CEO of the World Energy Council, was in the advisory board on sustainable energy for all of Ban Ki-moon, and have spent my past 20 years in energy at sea-level type of strategic way looking at the sector. So I'm looking at this from a very top-down kind of perspective. Emerald is Europe's oldest, most experienced clean tech investment VC firm. We have been around for 22 years. 70% of the people we have co-invested with at one time are no longer there, which tells a story about how difficult this sector is actually. It's a tough sector to be in, and And we are in a beautiful place today because the interest is really massively growing. So we have the biggest inflow of new investors last year historically, and we have an exciting play ahead of us, which is obviously doesn't make it an easy play nonetheless. Now, to this very topic, by the way, I'm leading the Energy Transformation Fund within Emerald. We have also a water fund, we have a sustainable packaging fund, we have a industrial innovation, more broader deep tech oriented fund. But here I'm clearly with the interest on the energy transformation side. And my initial take, I want to build on what Markus just said. I think if you look at the grid is extremely important, and it's totally inadequate in where we are today. With on the one hand, we have seen, as Markus has pointed out, that the supply move from the central to the decentral, which means that suddenly you have a huge production where before you didn't have any at all. You have with EV obviously huge consumption where before the consumption was much smaller. You have much greater pressure from a cyber side. You in the past, and probably that's another way of saying it, in the past it was simply not important to know what happens in a distribution network because it was boring. And today, today it's everything but boring. And the only way to manage costs in a rapid expansion pressure context is to bring some light in that shadow universe of distribution networks. And I think that's what this session is about. I think that we are very keen to see that happen. I think there's a lot of innovation needed in that space, so very grateful to be in that session.
That's great, thank you. And so it's exciting to see an implementer of technology, an investor in technology, and then of course a technology solutions provider in Corinex. So I'll have Peter provide his background and a brief introduction of Corinex.
So, hi everybody, thank you for having me here. Well, I'm with Corinex, I'm CEO of Corinex, and it's quite boring in my career. Before Corinex, I was with Corinex, and before that, I was again with Corinex. So I built, 3 companies as entrepreneurs. They were all successful. I am very grateful to this moment to be here together with Markus Hofsäß, who I met, I think, 2015, first time, when we came with broadband power line technology to E.ON, and we were trying to figure out, how it can be used and what it can do. Markus also helped to standardize these technologies worldwide in Prime Alliance. So technology today, which we are working with and we are deploying with utilities, is standardized in ITU and in Prime Alliance, and I believe very soon also in G3. So what we do, we are providing digitalization of the grid. There are many investors here, and all these investors created a lot of very nice energy devices, which are causing also a lot of problems in the grid. So with the saturation of the grid by electric vehicles, distributed energy resources, and so on, the grid has to be also upgraded. We are using as a core technology broadband power line chips. And when you hear broadband, you immediately think about the high speed, and you are right. Our fire rate speed is 1 gigabyte, but in reality is about 100 megabits per second in the electric grid. But in addition to that broadband speed, we are also providing computational power. So imagine, smart computers in the grid connected. As E.ON, I think, is testimony. We are providing very good grid persistence and security.
Great, thank you very much. Thanks for all the background. That kind of sets the stage for some Q&A here, and I'll try and take the most often cited questions that we get around this topic, and there may be time for questions as well from the audience, so if we pace ourselves well here. So Markus, starting off with you. As we talked about, lots of investments in these new devices connecting to the grid. As a grid stands today, do you think it's resilient enough to handle the integration of all these devices?
Well, the grid in the moment is by far not resilient. I mean, it can cover with what is pouring in the very moment, but we are really at the cutting edge, where the grid might collapse if we don't invest in grid expansion and in digitalization. I mean, it's a race. It's a race who is faster. The deployment of renewables that are very, very volatile, the deployment of consumers, electro vehicles, electrical heating, that is a very big topic in Germany in the very moment, and having the grid to be able to provide this energy. And of course, the demand is rising, and this can only be covered by expansion of the grid. It has to be done. But to cope with the volatility of the grid, the production, consumption at different times of the day, of the year, of the week, therefore we need intelligence to have a balance in the grid. And therefore, we have to hurry up and speed up in installing the technology, installing the monitoring technology, the sensoring, the communication technology to connect the sensors, but also to have the backend systems, to have all these controls to derive the right actions we need to our grid, and to balance, to fire up demand when production is high and vice versa.
Yeah, absolutely. So lots of different areas of investment. And Christoph, what are you seeing as the most interesting areas of grid resiliency investment these days?
Well, if perhaps stepping back a bit, what we see as the key drivers of the whole energy transformation, and I think we can then translate that into grid, is really, obviously, first of all, it's a decarbonization-driven transformation. And the key areas here, if you look at the energy system as a whole, first of all, we know that 80% of the energy, electricity is only 20%. So the first statement that we can make is obviously that if the only thing we have managed to decarbonize is electricity, really, right? The molecules, we are at the very beginning with thinking about all kinds of possibilities. There was a bit of biofuels, etc., but it's marginal, and the hydrogen is still, it's obviously, we have great ambition is great, the reality is small today. And so let's be clear, if you want to decarbonize, we need to expand from the 20% of electricity massively beyond that. And that's probably the simple thing. It's not simple by any means, but it's still the simple thing we can do. So that's your point about the heat pumps, the EVs, and everything. So there's a necessary explosion of demand, and the networks. Have you ever thought about how easy it is to build the networks where it's urban dense? There's no way this is going to be simple. There's simply no way. So every piece of intelligence that we can get that guides us through, first, what is transparency? Second, how do we debottleneck? Third, with what kind of minimal investment? Fourth, where are the flexibility elements coming from? Short term. By fifth, using those elements that are already in the systems. So how can I flex existing system portions, bring them back? Fifth or sixth, I think I'm in sixth already, but adding those elements that add the necessary top-up flex points. And then seventh, am I with eighth? To add the seasonal or long-term storage elements that are still missing if we take out. And there's so many more. So we can line up a long range of challenges. And I think the point I'm trying to make is the only way we make this affordable is by creating the maximum amount of transparency in the networks to help us guide through debottlenecking, building, expanding capacity exactly where it's needed, and I think that's what this is about. So we are very keen from an investor perspective, from a VC investing, to understand how we bring in the cheapest way, the information, and the flexibility to do that.
I would like to add one nice point to this. We need automation. The point is that we cannot operate all these requirements manually. We need some self-controlling, self-balancing nets. If we would run this as in the past, or from any operational centers or whatever, this is simply not to be covered. In the past, we had been talking a few hundred, a few thousand monitoring devices. Now we're talking about millions.
Yep, and that's a good segue into Peter. Peter, how will broadband over power line? How is this going to help?
I really enjoyed, these inputs from both gentlemen. Hopefully, after presentations over 5 minutes, one can do slide number 1 for the two. There is a problem, and number 2, and we are good to go. What is the resilience? I think it is capability of the system after some, special event to get back, right? And the problem of electricity grid resilience is that it is having, if it is not resilient, it is having several consequences. If there is a burst of a lot of data of electric grid, there can be blackout, and some people can, freeze, and there can be loss of the lives. If there is a run on the bank, like Silicon Bank, well, the bank will go under and nothing, big will happen. What we see is understanding of the scope or the size of magnitude of the problem. If we'll take on the substation level, one electric vehicle, one battery, one renewable energy generation, so 3 components, plus the household, and we are having 100 substations per 100 households per substation. So 100 households per substation, 4 components, 100 on power on 4, you will get number 100 million. So these are potential connections which one day we will be facing in saturated state of the industry of the electric grid. So now for this, we believe there is need for the broadband communication. Now, many people can say, well, we have wireless, we have 5G, and we have LTE, we have 450. The issue is we are talking about electric grid, and we need to understand the values of the electric current. We need to understand the voltage. We need to understand the phase angles. By sending broadband power line signals through electric grid, you can collect what is called signal-to-noise ratio, carrier frequency response, so you will get a lot of data from the grid. It's not only about transparency from device to device, it is also about you learning about grid itself, what is there happening. Now, the other thing what I see for a resilient grid, if you are having mobile network is excellent for when there is no special event, so the grid doesn't have to be so resilient. There is oversubscription, which is a key for mobile operators to make reasonable amount of money. Now, if there is a special event, then there is a storm of the data, and when utility needs most to access its devices, it cannot, because mobile network is probably clogged, and people are sending videos from what is happening. So we believe that utility needs to build its own independent network, and of course the natural thing is to upgrade its grid with certain infrastructure. So what we created, what we built in I would say what we built together with E.ON is broadband power line infrastructure, which sits on the top of the grid, collecting the data, enabling to analyze them, evaluate them, react, at a very high speed. So it's dedicated highway. Such a dedicated highway enables another thing. You know that grid needs to be secure. So there is need for security, at least with TLS, connectivity. If you are doing banking transactions or buying something with internet, you have this function in mobile phone, TLS on, TLS off. You know that if the network is good, you can use TLS. If not, then you cannot buy anything. So the grid, the data have to be all the time protected. That means there has to be persistent link. The other thing, what I believe, that the architecture of today energy grid devices which are installed on the low voltage part of the grid is legacy, is obsolete. What is wrong with it? In personal computers, in smartphones, you know that there can be third party which will come and which will upgrade the system. Right, so the all evolution in the industry of IT or in mobile telephony is not driven by one company which is producing the phone. Yeah, it is a key innovator, but there are other companies which are writing the applications. So if we want to really implement artificial intelligence, new algorithms and so on, you need to have open system, built on the powerful chip, which is broadband power line chip, and that is our focus also, to create such an architecture which we actually have today. The other differentiation of what I see going forward, the utilities will be, I would say, smarter or leaders in smartification, as I think it was told by CEO of E.ON, right? Smartification was the term. And some utilities will be not progressing so much in smartification. So this can also help the leaders in smartification, in digitalization, maybe to build these networks on top of the grid of the other utilities. So that can be one new business case. So these are my thoughts how to make the grids, more resilient. And I agree, it shouldn't be expensive. So it should be. No, I don't like the word cheap. Inexpensive.
Cost efficient. Yeah, cost efficient, exactly. That's great. I think it would be really helpful, Christoph, one of the key themes that is being talked a lot about is the democratization of the grid, giving more power to consumers. It'd be great to hear your views on what you feel the grid of the future will allow in that energy marketplace of the future.
Well, I think there's different aspects to that. And let me start with probably the unexpected one in a tech session. But one aspect, today there's still a lot of discussion around the behind the meter, in front of the meter, and who owns what and what is possible or not. If I, as a user, need to fight for my right to charge my car, future, it's not yet electric, but it's going to be soon, and I get any resistance or any constraint, then that's not a democratic grid. And I think so the regulatory aspects on how we treat the behind the meter, the symmetry that allows different things is not only something that is critical for this democratization, it's also something that will unleash a wave of business models which today are simply not possible. There's an artificial boundary, and I think I'm just going to put that up front. There is inconsistency in regulation across different regimes, and there is a whole blockage that disables a massive amount of business models to take off. And I'm saying this upfront because if you ask me what is my vision here, I think we will learn that this is wrong, and we will learn to open up this network in a way that unleashes those business opportunities. And then I think that's the first point. But I want to build also on the vision of what have we learned with if you are going to a network where we have the prosumer type or the consumption nodes kind of being displayed from centers to the grid edge, I think the only way to properly manage, and we're talking about balancing circles, right? Ultimately, the only way, think about this, in the beginning people thought of one big network that needs to be balanced, and there is one person who did it. Yes, it was a person who balanced those things. And I think this we have to, by necessity, move to a place if we don't want to just have thick lines everywhere. We need to go to a place where the whole balancing effort is going closer and closer to the grid edge, which means you balance everything as close to the consumption point as possible. And again, that is not possible if we don't have the intelligence. And I think you refer to you want to introduce nodes of intelligence and a neural network almost that can actually intelligently cope with different situations and activate or deactivate and help probably set price signals locally. So this decentralized balancing with the right transparency, with the right mechanism to adjust, be that through price signal, be that through automation, is a second pillar, I think, of this future of the grid. And I think I'm going to leave it with those two. There's other aspects, but I think regulatory, kill the behind the front the meter kind of discussion, go to much more grid edge balancing and enable the transparency and automation there is probably two aspects that I see critical.
That's excellent. Markus, do you want to add to that? Or because I'm going to ask you about the German reform.
I totally agree. We need new business models and how to act. And I think we also have to change our mindset. In the past, I have to pull my own oath, of course, but utilities consider the customer not as a partner, but as a problem. And we have to change our mindset in this way. He has to become the partner. We have to work out this together, and we have to develop business models in which we find a win-win situation, in which we get benefit out of it. I mean, we won't be allowed in the future to shut down all private appliances whenever we want. I mean, at some point the regulator would say, okay, stop it. Either you expand your grid that you can cope with the situation, or you find any other solution, but you can do this once in the case of an emergency, but not permanently. And at this point, we have to develop business models that cover the production side, that by intelligent tariffs, but that also covers the DSO side, that provides dynamic grid fees. And all this together must come to a automatism in which the customer decides, may I switch on, plug in my electric vehicle? May I use my dishwasher or my washing machine? Well, I mean, he won't decide for the dishwasher, but there are a couple of appliances. It doesn't care if you run them an hour later or earlier, and being honest, you want to use your car the next morning, 8 o'clock, with a 50% charging rate. You don't care if it's charged 9 o'clock in the evening or 5 o'clock in the morning. And we have to develop automatisms for the customer to be used that are controlled, that they support the grid demand and the production side.
Yep, absolutely. Completely agree. So the German Energy Reform Bill has obviously just come in, officially been adopted, correct? So it would be really helpful, I think, for the audience to understand a little bit more background as to that. And then, of course, now we've got to speed up the grid smartification. And so what challenges E.ON specifically and others will face as that really picks up in effort?
Just to bring us all to the same line, Germany has decided a number of changes in energy management. We call it the Easter package. That turns out in a high number of changes in national laws affecting the power production, but also heat consumption. For instance, we have recently a decision to that from next year on all new heatings have to be driven by at least 65% of renewable energy, that, or let's say more or less skips the use of conventional gas heatings, etc. We have change in the metering law in Germany that challenges the digitalization of the grid. We are now required to deploy smart meter gateways. That is the German approach for smart metering, that also encompasses control of private appliances via the same communication channels in a much shorter period to a much higher number of consumers. And all this together, there are a huge number of things we have to do. Brings a huge challenge to DSOs or to electricity companies. On the one side, the increase of demand in general, and we would, well, let's say last year we had a power consumption in Germany of roughly 600 terabytes. Until 2013, we assume an increase of at least 700 to 750 terabytes. This can only be covered by expanding the grid. So from our perspective, this means we have more or less to double the number of primary substations within the next 5 to 6 years. We have to build up the grid or expand the grid by at least 30% in medium and low voltage, 10 to 20% in high voltage. Tremendous challenge, a tremendous invest, of course, but a much bigger challenge than the invest actually is getting the headcount and the human resource to do this, what is challenging us pretty much. And a part of this, of course, everything has to become digitalized. We have outside as E.ON in the moment 200,000 secondary substations. All of them have to become digitalized in the next 10 years, let's say. We will build up another 100,000 in the next 5 to 6 years. Also, they will have to become digitalized, and we have to cope with all the data. A lot of models are yet not developed. Laws are not in place. You mentioned the regulator. There is a lot of homework to be done by the regulator that we can apply all these smart ideas to the customer that is not yet done. And these are all challenges that is driving us, where we are working on one side, the technical aspects to develop everything, but also to convince the regulator what we really need to be able to support his vision he has in terms of decarbonizing our society.
That's great. And can you explain where Corinex fits in the solution and why chosen?
Corinex is one of the key players in digitalizing our low voltage grid. As I mentioned, we are using the smart meter gateway in Germany, not only for metering purpose, but also for controlling private households. And in Germany, we already have the law in place that we are allowed to control and monitor PV plants, electrical heating, electro vehicles. And their power line is a very, very supporting pillar to reach the final customer. I mean, in Germany, the situation is communication is needed down in the basement. You don't get a public mobile or any mobile technology down in the basement, at least not in the coverage requirement we really have. And beside this, power line also supports the low voltage grid, since together with the technology itself, we deploy, included in the devices, voltage sensoring in our low voltage grid. In the moment, we are absolutely blind. All utilities are blind. There is no sensoring in low voltage grids, as you mentioned. It was boring in the past. And their power line provides voltage measurements of the low voltage grid that then can be used in our state estimations. That is clearly essential and very important to know for controlling our low voltage grid, to know where to shut down, where to switch and to shift energies, but also to know where to expand the low voltage grid. Where do we need additional substations? Where do we need an additional cabling, wiring?
Yeah, that's excellent. So Germany's clearly at the forefront of the grid digitalization. Christoph, love to hear your views on the different parts of the world and how they differ in terms of their progressive view, fragmentation, what's happening around the world.
Thank you for that. And just before that, perhaps let me just add one more picture that comes to mind. And again, with this, if we were in a situation where you had, again, the supply here and the consumer there, and you think of this now in your mind, think of a spider web. And in each of the circles of the spider web, call it a balancing circle or whatever you want, and you want ideally the production, the consumption, and the flexibility to be in each of those circles in such a way that it can almost self-sustain. It will never be able to totally self-sustain. There will always be value in exchanging. But I think the vision should be that the incentives are set in such a way that you build up whatever is missing in each of those small spider web circles. And I think that can only happen if you have the information locally. Why is that important? Again, I think it's ultimately the cheapest way to do it. It's the only way to have the renewable coverage as high as possible. And I think that's just a picture that I would like to leave. But worldwide, I mean, it's very different. And I'm going to pick up on a few points what define that difference. In Europe, and I'm coming from a country, Switzerland, where seasonal storage is absolutely huge, an issue. About somewhere between 5 and 10% of the consumption is winter deficit, if you want, is a consumption that that we can, even if we average on zero imports over the year, we still lack about 10%, up to 10% of the energy in winter. And I think that's just one example. And to think of different parts in the world, in a place like Latin America or so, where you have hydro dominated electricity system, and you talk about things like La Nina or El Nino, etc., with huge droughts or huge flooding suddenly, where it's not seasonal storage, but you have also those multi-year cycles where things fall out. Production is much more centralized there. Hydro is central, but some of the flexibility problems are in a way similar to the seasonal storage requirements. I think if you think of great city-states, obviously like if in a country like Switzerland and more broadly in Europe, you can almost think like, well, the surface of every house is that is that 1 to 2% of total surface in a country. It's almost enough to come up with the full energy that you need in a country. Huh? Think about that. It's almost enough that to cover the full energy needs in a country. I'm saying almost. The industrial, depending on the degree of industrialization, obviously you need additional things, but there's a lot you can do with rooftop. But the same is not true for highly dense places. Think of Singapore or a place like that. And again, there you have this very different challenge that you need actually. You still need a central production unit that has to cope with a large portion. So there is important difference. And I think they lie in the way how you think about seasonal storage. They lie in the things, how much you can really deliver, say, with rooftop type of things. And that obviously translates into a system. There is no single network, and there is not going to be a single solution.
Yeah, very good insights. And Peter, you've got pilots as well as commercial deployments throughout the world. What would be your perspective from those that are adopting quickly versus those that are thinking?
Yeah, well, if I may, I will go a little bit back to democratization, first. Today we sit here with E.ON, who is definitely the leader, in the world in renewable energy, but distribution. But what I see as a democratic grid, there'll be more energy devices coming to the grid, right? And we are all aware of it. So there'll be EV vehicles. Maybe one day it'll be Volkswagen supplying, grid with electricity. Maybe there'll be big battery, somewhere deployed by Shell, producing, also providing electricity. There'll be maybe, actually, I'll be selling electricity from my electric vehicle to my neighbor, of course, paying some money to utility. So I think this complexity of the grid, I want to say, more open is the grid, more democratized, it'll be more difficult to manage. So this automation, what Markus was mentioning, and this need for transparency and for the data and for the analysis, it will be only increasing. Now, we did such a proprietary map, as a company, what I call pain map. Tomorrow I have some, speech, so I can, share it with you. And we see that a country, like Germany, which is really leader in EV penetration, saturation, and in rooftops, is definitely, as a forehead of all these deployments, because in Germany there is 11 or 14% of the rooftops. In the United States, there is only 1%. So we see this coming. Now, the technology is currently in about 70%, I think, of the German utilities. So it is in Frankfurt, it is in Hamburg, it is in Berlin. And now we are starting with Netze. So I see that, very developed country in terms of, energy management, Germany appreciates that, this is something what is needed. Second country in Europe, in distributed energy resources, what we see in propagation of EVs is Spain. And, believe or not, we are in Spain in unnamed large Spanish utility in advanced commercial, pilot, which we believe will become, mass rollout in actually quite similar fashion to what E.ON is doing, as the utility is also helping to standardize this technology. The third customer I would mention is also in Europe. So then it is, utility in Czech Republic, large utility. So 10 out of 3 largest European utilities are in different stages of, validating of what we are doing. In total, probably in Europe, there are 2 utilities in Poland, which, successfully also, tested what we developed. And so I think that over the time we see these problems, if we will keep decarbonizing, these problems will not go away. They'll be only bigger and bigger. And I don't see any other solution. I have to say, well, that is what we are doing as broadband power line technology.
That's excellent. We actually do have a few minutes if there is a question from the audience.
Do we have any questions from our audience? Anyone would like to ask a question? Now is the time.
Great, yes.
Yeah.
You see, behind the pillar.
Thank you. My name is Emeka Chikure. I'm with E.ON. My question is, you've talked a lot about deploying this technology in existing cities with their density. Do you work with cities that are essentially being built from scratch?
Great question. Peter, do you want to take that one? So are you working with cities in which there isn't necessarily an established grid like E.ON has, for example?
Oh, yeah, I appreciate very much your question. So our first mass rollout, which we are not advertising, was in a Caribbean country, St. Kitts. So it was quite a challenging grid. We also validated technology in India. So it is, I would say, quality of the grid is not the problem, if that is a question. If it is about the density, I think Markus can better explain this, but E.ON is not utility so much operating in the cities, so technology is also good for the rural areas, for the larger distances. So distance is not the problem, and quality of electric grid is also not the problem.
Great, thank you. I saw another question.
Anyone, please raise your hand so that we can see you. If there's one more.
No? Okay, great. I think it would be really helpful if everyone gave their one takeaway that they wanted to leave the audience with. Christoph, should we start with you? Visions?
Well, I think, what we think is at the heart of the energy transformation is really the renewable play is one that has massive system implications. The renewable play is one of intermittence, it's one of decentralization, it's one that obviously can, through electrification, lead to a massive impact in what was in the past not seen as an electricity play, but all of that transformation, all the transformation can only then be part of an affordable trajectory if we use existing assets and supply chains in the best possible way. And I think and one example that I would like to highlight here, flexibility is not a battery, it's something that's already there and we just have to activate it. The only way we are going to do that is through digitalization. And that means, and I think that's really the essence I would like to think about in this session, is the only way we need to take every piece of infrastructure out of the dark space. And the distribution network is one of the darkest spaces out there. So let's start with this.
That's really helpful. Markus?
Yeah, I think my vision is that in the past we have been thinking the electricity grid top-down. We have to change this. We have to think the electricity grid bottom-up. We need the digitalization. Of course, we need all the information. We need the data. That's obvious and clear, absolutely. But we also need a decentralized control of the grid. We need self-controlling microcells behind one secondary substation that is organized by some intelligence in the substation and not centralized, monitored and centralized controlled. Of course, there is a emergency monitoring and control still required, but if we would manage all these tremendous amount of devices centralized, this would simply not be possible. We don't have the headcount for, and we have been talking about investment so far. We also have to think operational cost. And a centralized system is bringing operational costs to a limit that we won't be allowed to request from the customer in the future. The regulator will definitely close this and would not allow this simply.
That's excellent. And Peter, last words.
I just want to thank to my two great panelists or co-panelists for, I think they told everything already. So thank you, gentlemen, very much. Casey, thank you.
That's wonderful. Thanks very much.